Thanks, everyone. We'll get the webcast started in just a few minutes. We'll give people a few more minutes to join, so please hold on for just a second. All right, good morning or good afternoon, everyone. My name is Dave Graves. I'm a technical specialist with Autodesk. And today I'm excited to talk to you a little bit about Fusion Ultimate, specifically for our sim mechanical users. We're going to go through some of the different types of simulations, just educate you a little more about Fusion and why we're doing it. As we're going along, I have some colleagues that are incredibly knowledgeable on the phone, so feel free to type in any questions as they come up into the question panel, and we will try to address them as the presentation is going along. And if there's time at the end, we'll, again, try to take some additional questions. So thanks, everyone, for your time. What I want to do today, though, is I want to get started, and I know we have been talking about Fusion over our last several webinars. And what I like to do is launch a poll question and just get you guys to help me answer this. And basically, we just like to know how much you've been using Fusion at all, if you have or if you haven't. So just, we're going to give you a few seconds just so you can give us some input. All right. I apologize. I have to try to get you guys to see this poll. Beth, I'm not sure if you can help me, everyone, display this, but what I'm seeing is that we've got basically 14% of the people haven't even used it yet. Let's see. Can display this or not. So I'll give you the results. We have 34% have played with a little bit, 50% haven't even downloaded yet. So hopefully my goal is, at least by the end of this presentation, that we'll at least get you guys to pique some curiosity and at least download it, because you do have access to it. Here's what we're going to try to get through today. Just want to continue from some of our previous webinars. Want to go through, you know, what Fusion Ultimate is, what the capabilities are, and I'm going to also jump in and do some questions and answers. So, but before I do that, I have one more question I'd like you guys to help me with, and basically is, how much PowerPoint do you want to see today? I can go through about 100 slides and read them word for word. I can also kind of mix it up a little bit. So hopefully have a little fun with this. So please feel free to let me know. Let me think. Whoa.
Yep, and then
no one says 100%. Which button do I hit, Beth?
Sure. So after you close the poll, there will be a little button for share, right where the close button is. So then you can share it that way.
Awesome. Thank you.
Yep, no problem.
All right, so here's what we have, exactly what I thought. I am going to do my best not to PowerPoint you today. I do have a couple slides I want to go through just to give you a visual, but I'm going to try to get into the product as much as possible. So thanks for doing that poll for me. I definitely appreciate it. Let's continue where we are here. So if you notice some of the past webinars, we've talked a little about simulation mechanical being end of life in March of 2018. I just want to remind everyone, you still have access to it today. It's not going anywhere. You can still use it, keep your workflow exactly as it is today. There's no need to change. But one of the things I want to remind you is during the course of this year, you all should have access to Fusion Ultimate, and it should include 1,000 cloud credits per seat. We're going to show you a little more about cloud credits and how they're consumed and so forth. So again, keep using Sim Mechanical, but hopefully you're going to be excited about what's in Fusion 360 Ultimate today and then what's going to be in it tomorrow. So this is where I'm going to get excited, just to show you what's going on with these tools in our platform. So this is kind of a slide you've seen before, but going forward, again, today you can use Sim Mechanical. You have the option next year to really embrace Fusion 360 Ultimate and do some advanced FEA engineering with that tool, or you can continue to use our desktop tool, Nastran in CAD, which again has a lot of similar functionality with it. So just to remind you, you don't have to make a decision today. You have a lot of options going forward. But what I want to talk about today is when we talk about Fusion, why are we pushing this platform? Part of it, why are we end-of-lifing Sim Mechanical? And this is a definition from the web, the word Fusion itself. It's the process of joining two or more things to an idea to make a single idea or single product in our case. So that's really what Fusion is. As Autodesk, if we just step back and take a look at what's going on in the industry, the way people are building, designing, manufacturing, sending products to market is changing, especially with the internet, at an incredibly rapid pace. Hopefully in the call, no one's design cycles are getting longer, right? Everyone wants it faster, cheaper, and better quality, and that's what we're trying to do with our kind of our next generation of tools. We see the fact that we have a lot of design teams are virtual. We see this push for a lot of, mass customization, customized fit headphones, or I want my iPhone a certain color. We're seeing new materials. We're seeing this idea of generative and smart design, which is really fascinating, just really exciting for where everything's going. So because we see this world changing so quickly, we wanted to introduce a whole new platform. So Fusion, there's simulation in it, there's CAD in it, but it's more than just a single product. At the core of it is 3D CAD modeling, but what we're doing is we're expanding that so it also includes things like basic FEA, electronics, and then design is great, right? But people also have to the way they're building and manufacturing things, the explosion of additive manufacturing with 3D printing, some of the costs and the advantages of CNC machining. We want to have direct ties with that so we can help you make your product. We're also seeing more and more people, there's more and more smart devices. I've seen, smart refrigerators that'll let you know when you're out of milk, or your thermostats, Nest is a real big one. But the idea that these devices are going to be more and more connected. So we want to be at the center of that and provide a solution for all of these things. So think about, design, and you kind of saw that generative design or optimization, reducing weight, reducing material cost. All that is part of Fusion. And again, as we keep going, it's going to expand, and it's going to be a hub for, again, the way things are going to be made and designed in the future. So I'm excited to talk about it. When we start talking about simulation, and I promise there's only 3 or 4 more slides left, so thanks so much for bearing with me. When we talk about simulation, it's sort of the same thing, right? We kind of have this concept, we're really pushing for upfront simulation. I know some of you guys have heard the term, but the idea is that people can make decisions sooner and faster. But we also understand that, there's a lot of complexities in simulation, there's a lot of power. That's why everything in Fusion is Nastran based. So we want to make sure we kind of combine, make it a little easier to use, but still have some of the traditional capabilities that most of our Sim Mechanical users are accustomed to. And then we also want to have the simulation platform, I want to say be future-proof as best as possible. So we want to make sure that, we're going to be able to do things like, shape optimization, intelligent design. Who knows what the next requirements are going to be, but we just want to make sure we're at the core to do it. So we're going to talk a little more about this. And again, I'm going to get into the product and show you the workflow and how you can use it. But why Fusion 360 simulation? Some of these things, if you're doing simulation today, you're absolutely probably aware of this, right? We want to help you make decisions sooner. We want to get you to market quicker. And from a product, we want to help you disrupt the competition, disrupt the market, get your products out there and start taking market share from your competitors. And the thing about Fusion is it's fully integrated. And the idea being is that we're going to make it as easy to use as possible, and again, still have some of the power that you're used to. We're going to show you how the environment works. I'm going to show you how easy the help is, and really, if you guys are familiar with FEA and Sim Mechanical, this should be super simple for you to pick up. And again, we have a lot of tools that are going to help you do that. So that's kind of the idea behind Fusion Simulation, but what does it do today? I'm going to take a breath. Sometimes I go too fast. Webinars are hard because I'd rather talk with you than at you, but let's keep going. The beautiful thing about Fusion 360 is it's Nastran based. So Autodesk acquired NEI Nastran a couple years ago, and we did it for a purpose, is so we can provide leading edge technology to everyone, right? So we can democratize that. So everything is Nastran based. And if you look at this chart, the four basic ones are static stress, modal, thermal, and thermal stress are included in Fusion 360, we'll say the base version. Compare if we have any Inventor users out there, is that, Inventor doesn't contain thermal and thermal stress. So already we're trying to add more capabilities as soon as we can. We'll talk about the timeline, but we also have introduced buckling. We have a concept called shape optimization. You can kind of see down here in the corner here. And we're also looking at doing nonlinear. We just introduced some new material models. And then the really powerful thing is an event simulation. It uses an explicit solver and is really good for short duration type simulations. And I'm excited to show you some of the things I've done with that. Personally, I should say my background a little bit actually came originally from our CFD acquisition, and we had a fantastic way to compare multiple designs. To me, that's the most exciting thing we've introduced inside of Fusion, is the ability to do a side-by-side comparison, and I'm going to show you that today. On a side note, what you're going to see is a couple of these simulations are what's called preview. What that means is it's available, it works fine, but the preview gives our product managers time for users to give input, what they like about it, what they don't like about it. It lets us bake the solution a little better, and almost like dotting the I's and crossing the T's. So a couple of the features are still in preview, and then it's only a matter of time to what we call commercialization, or we'll say fully released. But today with Ultimate, you have access to all of these simulation types. Now, Fusion as a whole, I've been involved with the Fusion product for the last year or so, and what's exciting is it's a kind of a hybrid cloud product. It runs, we'll say, a thick client on your machine, but all the solving is done in the cloud, or file management is done in the cloud. And basically, for those of you that aren't familiar, we pretty much update the product every couple of weeks, and then every, we'll say, 6 to 8 weeks, we'll have a significant release. So the reason I want to talk to you about this or show you this is that while it may not have everything you need today, the pace at which we're adding more features and functionality is only accelerated. So when we first introduced simulation to Fusion, it was about 1.5 years ago in 2015. It just had static stress and modal analysis. About 3-4 months later, they added thermal and thermal stress. There's been a lot of other development, modeling, and additional technologies behind the scenes. And then a lot of that was, how do we take a tool like Nastran and use that for, leverage that solving capability? So there's been a lot of development there. And that enabled us in October of last year to introduce cloud solving. And there's some huge advantages to that. And we're going to talk about that literally in 3 minutes. And then once we had cloud solving, we introduced Fusion Ultimate around November of last year. Most of the features were in preview, but they were still available. And then in March, we took shape optimization out of preview. It's a fully commercial product. And then literally about a month ago, we expanded our nonlinear materials. So we've added things like hyperelastic with Mooney Rivlin, and we've done temperature dependent models. And I'm going to show you, just so you know, one of the things that's unique about Fusion is we actually publish our roadmap. So if you want to know what's coming, you can go to our website and you could look at this roadmap. This is a screenshot of what's on for simulation for the next, 3 or 4 months. By the way, the last release, these 3 were actually implemented. So we've already done things. We'll talk about study selector improvements and, for non-experts, how to help interpret your results. And then again, I talked about some of the nonlinear material expansion that we've added. We're going to continue to add, by the way. The next big thing coming is going to be model simplification and shelled elements, and just a little more better messaging. After that, the sky's the limit. So keep checking in, see what's coming. What I'm going to encourage you to do if you're interested is our product managers read our community post. If you like an idea, vote for it, give it kudos. If you have an idea, please post it, and they will take it seriously. They respond directly to the post. They'll learn more about your problems. So hopefully you can see that, Fusion is a big train, and we are just starting to ramp it up, and it's just exciting where it's going. So with that, that's all the PowerPoint I'm going to show. So hopefully that wasn't too bad for you guys. I'm actually going to jump into the product. Now, again, as I mentioned, Fusion is a hybrid cloud product. What it means is all of the data is stored in the cloud. Now, if you look at this interface, it looks like a traditional, we'll say a CAD interface. I have a data panel here. This is just a file structure, so I can see where all my files are. I can turn this on or off, by the way. Pretty simple. We have our model space here, and then here we have some ribbons. Now, the way Fusion is set up, it's one source of truth. It's one common model, but it's accessible from different workspaces. So simulation is a workspace that we're going to talk about today, but we also have photorealistic rendering. We have CAM, we have sheet metal, we have just a ton of different workspaces. So if you guys are getting started, the first thing you want to do is, how do I bring my geometry into Fusion, right? And by the way, I can create a new folder, just to show you this is all live. We'll call it the test folder. You can download it directly through the web, or right here, you just say, all right, I want to upload a file. So much like any CAD package, Fusion is going to have its own format, but these are all of the native files we work with. So you can bring your vendor assemblies up there. If you're working on SolidWorks, you can bring those up there. Creo, CATIA, step files, IGES, all the major files. So example is one of the files I've been working with. This is just a simple part file, but again, it works for assemblies. I'm going to bring in this gear housing. It's going to take a second, but it's going to upload it to the cloud and convert it to Fusion. One of the many advantages of being in the cloud is that we can update our translators much more frequently than when a desktop product, when you have to wait every year for the new update. We try to keep our translators up to date, a lot more efficiently. So once this comes in, I don't know if anyone, I know we didn't offer it with Sim Mechanical this year, but before then we had a tool called Sim Studio Tools. So one of the challenges with simulation is, how do you get models that are the right level of detail for what you want to do, right? Fillets, screws, threads, nuts, all those different things that you may or may not want in the model. So Fusion, at its core, it actually has a lot of direct editing capabilities. So what I can do, for example, is, I don't want any of that text. I can just simply click a button and get rid of that text. So it's very healing. I don't want this crazy fillet that who knows how that even got there, right? Just delete with my keyboard, and it'll get rid of that feature. This is history based, but if I wanted to track those changes, I could turn my history on. And as an example, maybe this hole right here, if I was to press pull, let's say it's a 7.5 millimeter hole, I only want it to be 7 millimeters. So it gives me some of that kind of exact precision built in. I can even you know, move entire features and fillets with this just to show you. So people, well, I don't have the design history, etc., but let me just show you this. I'm going to delete these fillets, and then if I wanted to, you know, I could say, well, let me move this rib here. Maybe I did some FEA and I decided it's not, you know, either I don't need it or I can slide it over. If maybe I need to get a part out of the way, who knows, whatever reason. What I can actually do is say, let me change the reference part of this geometry and let me rotate this. So if you can see, I could put this rib anywhere on the model. Hopefully that catches up. You guys can see it move. There it goes. Right? So again, you have all this functionality built in. So when you're ready to simulate, you can easily get rid of the detail that you don't need. So with that, let me back up and let's talk about how I'm going to do a simulation and the workflow and some of the other features with that. First thing, if you ever get stuck in Fusion, just go up here to where your name is and type in the help button. Everything it searches our knowledge base and it searches our help menu. So you could say, you know, whatever, nonlinear. And the help will go ahead and pick this up and give you all of the features and information that you need. It's super, and it's always updated because it's, again, it's in the cloud, so it's always updated. So feel free to do that. But what I'm going to do is jump into the simulation workspace. And if you notice, when this comes up, there's a couple things I can do. So these are all the study types. You know, the short story is today. These are all included with Fusion, and these are all with Fusion Ultimate. So it's kind of interesting how that worked out. But one of the things we're doing to try to make it easier for maybe non-simulation people is let me choose a simulation type, and let's answer some questions, and we're going to pick out the type of simulation that you want to use. We're going to continue to refine this and, again, try to make it more accessible for people that haven't done a lot of simulation. However, since you guys are knowledgeable, you know you want to do a linear static stress, so you just choose the analysis type. It has interferences, not a problem. I'm going to show you how we can check for that. But the key feature that I like is I want to do a simulation on this saw. I really don't need to bring in every single part. What I want to do is make sure, you know, this is the heaviest part of my model, this housing and this motor, and I just want to make sure it's not going to deflect. I want to make sure the housing for this is strong enough to hold it. So check this out. I can just select the parts that I care about and say suppress all except selected. What that does is it gets rid of everything I don't need. So now I don't have to go through a feature tree. I don't have to figure out which parts to suppress. One button, I get the model that I want. I think it's one of my other favorite features. Much like a lot of our other tools at Autodesk, I'm going to work from left to right to set this up, right? So material. It pulls it directly from Fusion. You can make your own material database if you want to. Linear, nonlinear, it's up to you. I'm going to do linear to start, but really simple to apply different materials, do a lot of other scenarios. Now I'm going to go to constraints. I don't know if you see this. There's a little C right here. That's a hotkey. So if I hit C on my keyboard, the constraint menu comes up. For this model, I'm just going to simply kind of fix a couple parts of my handle here. And then, you know, I have some symmetry. So I can pick this symmetry edge. I could go ahead and specify, you know, which way the faces are constrained, but I just like to use this frictionless constraint. Got my constraints set up. Just if you look at these are all for people that do simulation. These are all pretty typical things you're going to find in sim mechanical or some of the other tools, right? Now I need to do some loads. I want to turn gravity. I get a nice visual. I can just double click this to edit this if I wanted to change the direction or the value. So it would give you nice visuals as you're building this. And then I want to put a little weight on here for my motor. I know I have gravity, but here's another nice feature we have. I can pick a certain point. I don't have to split the surface if I know maybe I want to split the difference between where the motor is and where the gears are. So I can just, you know, put an actual concentration point in there. Just a pretty nice little feature. And then maybe I'm going to give it, you know, a couple pounds force here. The nice thing, I can switch units. Doesn't matter which units I'm in. I want to put it in pounds. And I pretty much have everything going on here, ready to go. But if you notice, I have a warning here. And again, just to make it easy to understand what may or may not work right, when I click warning here, it tells me something about my constraints aren't fully defined. We have a beautiful degrees of freedom viewer. So when I click this, I can see right away that there must be missing a constraint or contact or something on that gear housing. I get a nice visual so I can see what the issue is. In this case, there's no contact, so no worries. I could manually, put some points on there. I should say before I get too far, we actually can do some bolted connections as well. So that feature's in there. I think it's a little easier than Sim Mechanical. I've dealt with that tool in a while, but check it out when you get a chance. But I'm going to automatically do my contacts, and by default they're bonded, but I could, if I wanted to do a separation contact, I can make that the default, and I can change them. So if I go into my contacts, just to kind of show you here, these are bonded. As you select them, you can take a look at the different surfaces you can see right there. But I can do separation, I can do rough, I can do offset bonded, a lot of the things you're familiar with in Sim Mechanical or even in CAD. I can also do, put in stiffness factors, friction values, a lot of the same things you're already accustomed to. So again, I'm not a heavy user. Maybe I'm just going to do bonded contact. I'm more detailed. I want to understand the problem a little more in depth. Hey, great. I can use some of the traditional contacts that I use now. Okay. So if I go ahead and look at this now, it should say information is ready to go. Now, here's where it's pretty exciting. You actually have the option to solve this locally or solve on the cloud. As you saw earlier, you get 1,000 cloud credits with each seat of Fusion Ultimate. This simulation would be 5 cloud credits to run, or basically equates to $1 cloud credit. Maybe I don't want to use cloud credits. I want to run it locally. Fine, I can just click it locally. Be aware, it's only going to be local to that machine, so you can't send it to another machine on your network, but it does run pretty quick. One of the negatives about running locally is I can't really do anything else in the interface. Much like today, if you run something locally, it'll do everything kind of sequentially. But that's okay. We'll show you the cloud in a minute. So that's probably one of the disadvantages to actually running it in the cloud or running it locally is it does kind of lock up your machine. But one of the advantages of the cloud, so I know I'm changing gears for just a second, but everything that you do is actually stored in the cloud. So I've made a little project here called Fusion Ultimate. I'm going to go right into the model that we're looking at, right? So it should tell me that one of that saw is probably being updated, but I can actually go and interact with this in 3D. So this is a neat feature that hopefully you're going to see. I'm going to be able to communicate my simulation results. I'm going to be able to communicate my design intent all inside of a web browser. So even though while this is running, I can take a look at the model. Let me see if this is almost done here. It's almost done here. I can take a look at the model. I can mark this up. So I could say, hey, I think this might be a weak point. If I could type, I'd be dangerous. Oh, there it comes. Anyway, so it just finished. So it doesn't take too long to run locally. But once it's done, this is where we're trying to make this a little easier for people that don't use simulation a lot, but still going to give you all the things that you need. What we did is we highlighted the area where it is below a certain factor of safety. In this case, we made it below 3. You can customize this. So maybe you're working with designers, you want to give them a factor of safety of 10 because you want them to be ultra conservative. So you can work to do some things of this. Like this, but right away I can tell that, hey, this is where my weak points are, right? They're right where the attachment point or the embossments are. I can make it the actual deformation and adjusted deformation, all the traditional things that I want to do. But if I want to change and look at displacement, for example, it's just a button click. I can tweak the scale. You can see the max. I could also go under inspect and do some surface probes. I can create slice planes like I can do with SimMech. Surface probes, again, I can put this on here and get this displacement value anywhere in the model. Let me go slow that down so you guys can see it. Right, so that's pretty exciting. And I'm gonna maybe do something a little out of the order here, but if I look at this and I look at my safety factor, this is where, all those who use simulation, it's the great advantage. I can see where it's going to fail. I need to add some more support here, right? So one way to do that is just to create some ribs, but I want to make sure that I'm putting them in the right place and they're effective. So what I'm going to do is make a copy of this model or simulation. I'm going to go into modeling, and I could spend hours going through all the features and functionality for how you model in Fusion. But I'm going to show you something real simple. What I'm going to do is just, I don't know if you notice this, it picks up these center points really nice. I'm just going to put a couple lines here, kind of ballpark in the middle, right underneath where those attachment points are. We have a feature here called Web. If I click this, and I just click these two open lines here, come here, line. Get this here, sorry. Stop the sketch. And I'm going to do this web again. This line and this line. Way to go. Let me go back here. Of course, it's working great all day. All right. You can tell I'm doing this live, right? Because we're having all these wonderful issues. Let me try this again. But the idea is that I can simply pick these lines, and it's going to automatically do a nice little rib for me. So let me do this one more time. Thanks for bearing with me. And there. And there. And should be able to. I'll just do them as two different ones. Now, what I can do is put an exact value. I can also parameterize that. So I can make this a thickness right here. I have one. Usually I do them at the same time, but it is not cooperating with me. I always like to blame it on GoToMeeting, so that's what I'm saying is messing me up here. And then I can do another one. There we go. Thickness. So these are the same. So I have these two webs here. And let me save this. I want to see how effective those are going to be. Now, just on a side note, this is version 3. Every time I save it, we automatically up-rev it for you. So it's going to automatically go to version 4. And the nice thing is that it doesn't delete anything. So if you ever make a mistake, you can always go back to a previous version. So if you notice, I have the new geometry here. Right here, it says, oh, static stress. It says this geometry is out of date. Absolutely, because I added those ribs. But what I can do is solve this one in the cloud. We'll solve in the cloud. And save these first results. This is a little trick that I tell people, that save this first one, make a design change, and run it again, but save the results so I can go back and compare them. But let's say I also wanted to run this with nonlinear, right? What I could do is clone this. Again, because it's in the cloud, I can continue to work, right? I'm solving in the cloud. That's one of the advantages of the cloud. But I can go in here and say, you know what? I actually want to go through and I want to do this nonlinear, right? And I want to change my materials. Again, I have a nonlinear plastic in here. We have some metals in here. Oh, there we go. Let me change this. Not sure how this happened. Change my materials of my housing and change everything else. I can go ahead and run this. Let's just do this. I'm going to solve this in the cloud while we're running here. And just some other controls that you have. As a user, right, I know a lot of you guys, you probably want to be able to tweak the mesh a little bit and do some other things. Not a problem, right? Inside of Fusion, if you go under Manage, there are going to be some local mesh control. So in here, you can pick a body, a face, or edge. So I get a nice preview. I get these dots, you're seeing a nice modal preview. But if I wanted to make sure that, this attachment point had a much finer mesh, I can absolutely go in here and put in a value and slide it. So I could change the mesh that way. I can also go in here. We have a simple slider, so I could tighten the mesh with a slider. I could go in there and put an absolute mesh size in there. I could change to linear elements versus curved mesh elements. Before you ask, no, there are no brick elements. But feel free to post that if that's, again, go to the idea station if that's a big concern. So it's all text, but that's the meshing process, so you do have some control over it. So you can go in, again, you can tweak some things. Another thing that we implement in here is, let me go back to make this linear, right? Another thing we can do with linear stress, I think we have it for nonlinear stress, is I can do adaptive mesh refinement, right? So what I could do is say, okay, let me just start out with my default mesh. and let me run an analysis. It'll look for the high concentrations. It'll remesh. In this case, it'll do it up to 4 times or until it convergence. So that mesh adaptation, automatic mesh adaptation, is built into the tool, right? So again, feel free to try that. This should run locally or in the cloud as well, but that's another way you can get to your ideal results faster. So I have a checkbox. This one is done. I have a notification here in the bottom. And again, I apologize if I'm going too fast. I just want to make sure I, cover everything with you guys today. So here at a high level, if you look, I get a double check mark. There's no warning. I have a super high level of factor of safety here. But here's where it gets fun for me, right? Why don't I go and start comparing these two designs? So the first thing I want to do is I want to synchronize everything. And I can say this one is the first one that I did on the left, and the one on the right is the second one that I did, right? So if you notice, everything is being kept to the same scale. So obviously, I have a really problem with my factor safety on the left. Any quantity that I change to, so if I change to displacement here, let me spin this out a little bit. If you notice, this has a high of 3.318 millimeters. If you look here, I've reduced that by adding those ribs there. I reduced it to less than 0.3 millimeters. So obviously I did these in the right place, but I could go through, you can actually, if you look at your layouts here, I can view up to 4 windows at one time. So it could be different load cases, it could be different materials, and as you can see here, it can be different geometry. So to me, I just think it's huge, whether I'm a simulation expert or I'm a designer, it's huge for me to be able to go and compare these. Oh, and everything on the web, I kind of glossed over it a little bit. If I go back into my saw, just to show you this, let me save this here. All these results become viewable on the web. So if I go to my saw here, and I go to view my results, or view my model, when there's a simulation, there's going to be a little icon right here. What that's going to do is open up your simulation tab. So if I wanted to look at, now the design compare is not in here yet, but if I chose a certain model here, get my displacement here. I could look at the first one, I could look at the second one, I can mark this up. It's going to take a second to load, but you can see here, take a minute to paint, but I can actually kind of see what the displacement is with that model. I got to turn a few things back on. But that's the idea, is I could actually go into the web and view and mark up this model. So just kind of be aware, there we go. There's my safety factor. There's my stress, right? All inside of a browser. It works on a mobile device, works on your iPad as well. So again, that's the beauty of Fusion being this hybrid cloud product, is I can take it and I can not only do simulations, but collaborate in whole new innovative ways. All right, another deep breath. So again, going through the different simulation types, if I wanted to, as another example, I could do a buckling analysis, make sure that the part of this saw is not going to buckle, or I can, as I wish you guys could see my hands, as I'm pushing this forward, making sure it's not going to break. So that capability is in there. Some of the really exciting things that maybe you're not going to see in SimMech today are going to be something called shape optimization. All right, so what shape optimization does, and you may have seen them showed in Inventor, it's similar to Inventor, but I think it's got a couple of neat features that Inventor does, is let's say I'm designing this monitor stand. And what I want to do is I want to, reduce the weight here. It's a little heavy. I want to go in and see where I can take weight out of the stand. I could do just an FEA analysis, and I could see the stresses, and I could iterate back and forth and try a bunch of different things, but I want to do something a little bit different. So what I do when I enter the simulation world, again, a new study tape, in this case, shape optimization. It's kind of interesting. So first thing I want to do is just pick these two parts. One of the big I think I have 3 parts. One of the big differentiators is that I can work with multi-bodies and multiple parts. I can't do that in Inventor. I really just have to work with a single part. So I'm going to make sure I choose, these are some spacers here. And let me get the last one. back the other side here. Sorry, my screen's all jumping around. And the same thing I did before, right? I'm going to do suppress all except selected. So now I just have my parts in here. I can go ahead and assign different materials. We'll just keep them all steel, or maybe I'll make one aluminum or plastic or whatever. And then I'm going to, like I would a traditional analysis, is set up some constraints. So I'm just going to fix the bottom of this. In this case, maybe I'm just going to put a downward load on the actual monitor. Now, I do want to make you aware of something. Whether you put 1 Newton, 100 Newtons, 10,000 pounds, it's basically just a single scalar value. If you put multiple loads, it's going to be a ratio. So this is not full-blown FEA, meaning after you come up with a finalized design, you have to go back and run a static stress or whatever simulation you need to on it to verify and validate it. This really is just going to look at a load path. So again, just want to let you know that beforehand. But the same thing, I have some loads here. Now again, I probably don't have any contacts. I'm just going to generate some contacts. It's going to find all those points for me. And then in this case, if I go through here, what do I have here? Oh, yeah, I need some optimize. So it also says, hey, what do you want to optimize here? You have all these parts. So it is limited to one part, but I can say, let me optimize this bottom base here. Awesome. And then now let me go through and I can do some preserve, I can do some, preserve some regions. So let me say what I want to do is I want to make sure I have the part where the monitor is going to mount. So it's going to give me a little region here, and I can change this size. So I want to keep a place to mount this actual monitor. So say, hey, let me keep this as part of my simulation. And then I can go through and say, all right, maybe as a target mass, I want to do, I want to make it 25% of what we have now. And I want to go and maybe try some different mesh settings, maybe make it a little finer, all the different settings I might want to do. Here is, to me, is where the cloud's going to pay huge dividends. So that's one idea, one sort of optimization. Let's shoot for 25%. What happens if I want to shoot for something more, right? So let me say, hey, oops, all right, let me say I want to do 15%. Okay, make a copy there. I can rename this. Let me make sure I don't click it too much. 15%. All right, let's make another one. Let's do 50%, right? So that's the idea, is I can maybe set up a lot of different things, try some different mesh size settings, try some different, maybe a different constraint. Doesn't matter what it is, right? Let me find this. Here it is, sorry. We'll make this 50%. The idea is it's so simple to copy and paste these, right? I can make a lot of different things. Make this 50%. And when I'm ready, go to my solve button and say, all right, let me solve all of these at the same time. Right? So it's going to go ahead and solve those. And when it's all done, I can go and view them all. So here's an example. Actually, let me open one right here. Running right there, but let's open this one up here that I've already run and take a look at it. Couple other examples, right? So part of it is, yeah, maybe you want to actually take weight out of it, but here's a pretty neat one, right? Let's show results view here. Check it out, right? It went through. Got a neat product here. Put the struts and supports where I need it. I could design over this. We have a tool called Remake. I could convert it into, different organic shapes. What is 50% is not going to look nearly as good, right? Because, I didn't add as much mesh to it, but again, I'm keeping a lot more of the material. So part of this, and I can, by the way, let me go back. I can change what's called the load path criticality, so I could kind of add more material, take away more material, and then, a lot of flexibility here. But all we're doing is looking at the load path. But again, you can really give you some creative ideas, right? Here's kind of an example where, understanding, sure, I want to have a final design and I want to, have something that's going to be structurally sound, but maybe I can use it as a design creativity tool, right? The image I'm going to show you, oops, wrong one, is basically this chair, right? So for this chair model, you can see the thumbnail up here in the upper left-hand corner. with the chair model, I just said, well, here's a chair, let me just bolt a cylinder to it, and then let me let Fusion come up with a couple of ideas for what that chair is going to look like. So let me give this a second to load. But the idea is I can, rapidly look at a couple different types of scenarios, whether it's mesh size, we have the ability to do different target member sizes, but I can go through and just come up with new and different ideas and different ways to approach the problem. All right, so that's what my chair looks like. It's kind of better I opened the wrong model. It should come from this model. But you can see it kind of went through here. By the way, it's okay that it failed. What it was telling me, I know the error message just says, I can't reduce it based upon your mesh and your settings. I can't get rid of 85% of the material. It'll tell me in the file, maybe I can only do 18% or 22%. So in a way, it's going to give you an idea based upon the load path, what's reasonable as far as a weight reduction goes. All right, so let me let this one load. But you can see here, right? This was again generated from this shape optimization. It took a look, and as you'd expect, it got rid of all the material kind of underneath here, and it left me, what do I need, to physically support this chair? So, sometimes it's pretty intuitive. Sometimes it's like, I think one of the to me, one of the best things you can do in simulation is like, I didn't realize that, or I never thought about that. And that's kind of what we did here. So if you look at this chair, there we go. There's my chair. So by the way, this whole top part was done with our freeform stuff. It's pretty powerful. We haven't even talked about that, but a really neat way to do organic shape modeling. All right, so I have about 10 minutes left. So what I want to do is talk about, the other kind of, we'll say the really new whiz-bang powerful feature here is something called event simulation. I know SimMechanical has MES, and it's similar and different to MES. Today, again, if you remember, this was still in preview, right? Today, the solve time is going to be limited to 12 hours. So the software is going to go based upon the settings and the mesh and the material. It's going to be able to determine, how long it's going to take to solve, whether that's, again, if it's longer than 12 hours, you'll get an error message saying the simulation, exceeds the 12-hour limit. Just be aware that's going to change in the future once it's commercialized. Once it's commercialized, you'll be able to solve as long as it needs to take. And so today it's really good for short burst, really quick items. So an example, here's an axe, right? So what I want to do is see, maybe based upon a velocity or force, can it go through and break through these boards? Right, so again, the study type, if I go into study type, is just going to be this event simulation. And much like any other simulation, I'm just going to work left to right. So the materials, to show you the way they're all set up, is I have wood for the boards and steel for the axe. Again, I could put a wood handle on the axe if I wanted to. I think in this case, you can make the axe a rigid body. You're not worried about the axe breaking. But if you wanted to see where the handle's going to break, sure, make it wood. And as it goes through, you can see if it's going to crack or break here. Right? Similar constraints, I would probably, fix the bottom. You can see the icons, you get the locks, so you can physically see where those constraints are. And then, the loads. In this case, this was given, I should just open my loads here. This was given as an initial linear velocity, so we pushed this whole axe handle down. So that's typically the way it works. You could, if you were going to do a drop test, it'd be the same thing. What way is gravity? How fast is it going just before it hits? So you want to model things as close as you can to where they're going to be. And then, you go to the settings, is for how long do you want the event duration to go? There are parameters. I should say you can do a transient step for the time. And then here's where it gets interesting. This is something SimMechanical doesn't do. But if I want to see how things actually break, I can allow for element deletion, right? So what that means is when I run this, check this out. Here it goes. Bam, it actually breaks through the board, right? So if you remember that video you kind of saw at the beginning, that's this wall right here where there's a ball actually going through and actually, again, breaking through the wall. So I can turn that on or off, but it's just a neat thing, right? Most of the simulation tools today, instead of breaking, you just get this big infinite stress and it gets redder and redder and it deforms like crazy, but you never really see it break. So the ability to do that to me is incredibly powerful. I just, I always joke sometimes showing the product is I actually get paid to do this all day. What a great job I have just to be able to investigate things like this. Here's another one, right, where I have a daughter who actually tried to take lacrosse, so she's pretty excited. But, check this out. I'm just looking at the stress as this ball hits this lacrosse stick. Where are my high stress points? Where am I going to be concerned? Again, we could look at the overall displacement of the part. We can look at, acceleration and velocity. So a lot of neat things like that. And again, here's kind of the wall going through again. So the process is going to be the same. You can do initial velocities of parts. You can just do force. You can, again, have a rigid body for a floor that's going to get hit. So things like drop test. This is a force fitting. It supports linear and nonlinear materials. So some of those gasket type things, you actually want to see things compress over a quick period. Just some neat, powerful things you can do with that. So just wanted to give you guys, I want to be respectful. I know we have about 8 minutes left, but I want to make sure, if you have any questions, throw them in the chat window. I know I have Vic and Mike on there. I don't know if there's anything specific. Let me take a look at the questions that we can answer. But again, actually, let me back up, right? To download it today, you guys have access to it. Let me show you this. Go to just AutodeskFusion360.com. See the products here, or product Fusion 360. Just download the free trial. Oh, sorry, come here, you. Download the free trial. If your contract is set up, you have the entitlement tied to your license and it's tied to your ID. When you download it, you will automatically have access to Fusion Ultimate. So it's pretty simple to do. Literally, the download takes an installation, I kid you not, take less than 5 minutes. So it's not like you're downloading gigabits and you're waiting, 4 hours for it to install. It's super quick. So with that, let me see if we have any questions come in that I can. Hopefully you guys found this useful. I apologize if I went a little fast. Again, I just want to make sure I got through a lot of this. So let's see. Vic, Mike, any good questions up there?
Hi, Dave. This is Vic. No, I think this was really good. Thanks for taking the time to share all of this. I think you called out quite a few things, and it's amazing to see in the short, year or year and a half, we've really power packed the Fusion 360 platform with quite a lot of functionality, and it's only going to continue to grow. So I think that's really appealing. Some of the key things like shape optimization and event simulation, I think are just cutting edge technology that we're now able to provide with the same level of ease of use for our customers. So I think that's really fascinating. The one thing that I did want to emphasize on, and then you can certainly call out a few questions, is that all of our sim mechanical customers should have access to Fusion 360, as part of a grant, a 1-year grant that we have already provided. It will appear in a separate contract though, so if you don't see it right away, we suggest that you get in touch with your contract manager so that they can add your A360 credentials to the contract in which the Fusion 360 provisioning has been done. So you should be able to access Fusion 360 and download it and start experimenting with it right off the get-go.
Awesome. Thanks, Vic. And I know at a high level, some of the things that aren't in there today would be advanced vibration and fatigue. Again, I encourage you guys to, if you're interested, go on the idea station for Fusion, submit the things you want to see. If you again, the product managers, they will listen to you well before they listen to me. And if there's a need for it and we see that coming up and it could be implemented, that's the place to get your ideas into the product. So I encourage you. And again, I know, I think 56% of the people haven't even downloaded, or well, 70% if I look at the whole thing, haven't even downloaded yet. Take a few minutes and try it. The idea is we just want to understand what's available today and understand the workflow. And feel free to reach out to us if you have any questions. We would love to talk to you more about our products. And thanks again for your time. Really appreciate it.
Hey Dave, just one more thing to add. So if you can, in the data panel, if you can show everybody where the simulation samples are.
Oh yeah, sorry, great. I should even just let me talk about that further. Right, again, if you go to Learn Fusion 360, it comes up with a bunch of different examples. But as Mike said, we really want to make it as easy as possible to use. When you install Fusion, there's a whole directory of simulation samples. There's hands-on exercises. This is all the accuracy verification, and then these are some of the event simulations like you see here, this press fit. But yeah, that's a great place to start. Just go check out some of these examples and get a feel for how the workflow works. Thanks so much, Mike. I apologize for forgetting that. Appreciate you bringing it up.
Yeah, and then one last question that just popped up because I don't think we covered this clearly. Tommy's asking, can you solve anything locally that you can't solve on the cloud? I think is how it's written. So just to be clear, Dave pointed out that there's 8 study types. There are 4 basic study types: static stress, modal frequency, thermal, and thermal stress. All of those studies can be solved locally or on the cloud. When you install Fusion, if you try to do a local solve for the first time, it will do an on-demand install of the Nastran solver. The 4 study types in the second row, structural buckling, nonlinear static, event sim, and shape optimization, are all cloud solve only. While nonlinear static and event simulation are still in tech preview, they are free of charge. So feel free to test drive those. And as Dave said, if you encounter issues, let us know on the forums or on the support ticket. And for those of you who I didn't do a great introduction, some mechanical names I see here and recognize from my days in Algor. My name's Mike Smell. I was an Algor application engineer, starting with them back in 2006 until we were acquired. I've done a couple different roles and job titles here at Autodesk, but I am now the product manager on the Fusion 360 team, responsible for the simulation workspace. So anybody that remembers me, feel free to reach out. And anybody who is not familiar with me, any feedback that you have, would certainly love to hear it. The other thing that I'll just close with, Dave has given you guys a good overview. As he pointed out, the roadmap is very public. That thing is updated, every couple months. So as things get completed, as you saw, we've completed, I think, 3 out of the 6 items that we've had listed. As we complete a couple more tasks, we'll probably be, defining what the future looks like behind that. So, one thing in Fusion world as compared to sim mechanical, as Dave pointed out, we're releasing software, I think it is every 4 weeks right now. So basically once a month. Our development roadmap and our development process is much, much more fluid than what you might be used to with sim mechanical. So we will be making good progress, as we continue to move forward, focusing on, number one thing is usability. As Dave pointed out, you'll see there are, many of the traditional workflows that everyone is familiar with. We're doing things like the study selector, the help there, the results interpretation, the compare workspace, things like that are really focused on usability for new users to make them successful. But we're also, balancing that with adding technology, right? We've got event simulation and shape optimization, which are technologies that would not have showed up in sim mechanical. We've also been, working to close the gap for advanced things like nonlinear materials, where we've just added, a number of those new material models with our last update at the end of May. So, things are happening where we're trying to balance the depth of the technology and the usability and the ease of use of the product.
Awesome. Thanks, Mike. Thanks, everyone.
Mm-hmm.